This video is about yield, and yield is really important for industrial chemists, so people making chemicals that they want to sell, because yield is how much product you make. So if you remember, in most equations you have reactants on one side, those are the substances that react together, and products on the other side of the equation, the things that are made. And the yield describes how much product is made. And normally you're talking about one useful product of the reaction, and then the other things are often waste products. So you can calculate how much yield you would expect to get from a calculation if you put certain masses of reactants together. And for higher tier you will have to calculate this yield, and it is called theoretical yield. So I'll write that down here. That's if you do a calculation by working out the masses of the reactants, how much theoretically could you make? If all of those reactants turned into products, how much could you make? And that's the theoretical yield. Then, once the reaction actually happens, the actual yield is the actual amount you make. So the actual yield is the actual amount of products that you make. So once you've weighed the products at the end of the reaction, how much did you actually make? Not what you calculated you might make, but how much have you actually made? And then the final word you might see associated with yield is something called percentage yield. And for the higher tier, you'll have to be able to calculate the percentage yield, and for foundation you just need to appreciate that at the end of reaction the actual yield that you get will be a percentage of the theoretical yield. So if you assumed by your calculations that you would get 100 grams of product, when you weighed it you only got 80 grams of the product, your percentage yield would be 80%, because you've collected 80 grams out of the potential 100 grams that your calculations suggested you should have made. So your percentage yield is the amount as a percentage of the theoretical yield that you assumed or calculated that you could have made from the reaction. So obviously if you put the reactants together you would want to make your theoretical yield. You would want to maximise the amount of product you made. But there are several reasons why this value is never going to be 100%. So this yield that you get out will never be 100%. You want it as close to 100% as possible, but it will never be 100%. And you need to know 3 reasons why you will never get 100% yield from a reaction. And the first reason is because the reaction may not go to completion, it is reversible. So in reversible reactions you have substances reacting together to make products, but you can also in certain conditions have these products reacting back together again to make reactants. That's why you get that double-headed arrow on reversible reactions. So that makes sense. If you have A and B reacting together to make C and D, you're not going to make 100% C and D all the time, because these products can start reacting again and turning back into reactants. So that's one way that you might never get 100% yield. The second reason is that some of the product may be lost when it is separated from the reaction mixture. So for example, you could be filtering your product into a conical flask, for example, and you all know the filtering process that due to the nature of it, some of your product may well be lost on the filter paper and will not all collect in the bottom of your flask. So this will mean when you come to weigh this product in here, it will not give 100% yield because some of your product has been lost when separating the mixture, and this could happen on a number of machines or equipment. And finally, some of the reactants may react in different ways from the expected reaction. So that could be, for example, if you are heating two reactants together and you wanted to make the products, it could be that actually one of these reactants could have reacted in a different way, for example with oxygen in the air, or reacted somehow with another substance in the equipment, and therefore you would not make all of your product. So this is one other reason why your percentage yield will never be 100%. So you need to think of these three reasons when asked about that question in exam. But if you're a higher tier, please continue watching the video for calculations on percentage yield. So to calculate percentage yield, you need to do actual yield. So the actual amount that you weigh of the product that you've got at the end of the reaction, divided by theoretical yield times by 100. So the actual amount that you weigh at the end of a reaction divided by what you thought you would have got of the reaction through the calculations times by 100. So in question 1 here, the theoretical yield of calcium sulfate in a reaction was 131.6. However, only 98.3 grams was produced. Calculate the percentage yield of calcium sulfate. So for the percentage yield of calcium sulfate, we need to do actual, which is 98.3, divided by theoretical, which is 131.6, times by 100, and on our calculator to help us, 98.3 divided by 131.6 equals, times 100 equals 74.69, so I'll round it up to 74.7% yield. So not 100% because our reactants could have reacted in a different way, or it could have been a reversible reaction, or it could have been lost during the separation process, as discussed before. Now question 2 is more often than not the scenario that you will find percentage yield questions in. So this is just a simple example, but really percentage yield normally ties in with a question on theoretical yield. So we're going to combine the two here in this question. If you're not sure how to calculate theoretical yield, I'd recommend first watching the video on theoretical yield calculations. So 63 grams of calcium reacted with sulfuric acid to make 153 grams of calcium sulfate. Calculate the percentage yield of calcium sulfate. So we've got 63 grams of calcium reacting with sulfuric acid to make 153 grams of calcium sulfate to calculate the percentage yield of calcium sulfate. So first of all, we need to calculate the theoretical yield. So we've got the actual yield here. This is the actual yield that we've got. First of all, we need to calculate the theoretical yield. So to do this, we need to find the relative formula mass of our reactant end product. So we need to know calcium and calcium sulfate. First of all, we check to see whether the equation is balanced. 1 calcium on the left and on the right, 2 hydrogen on the left and the right, 1 sulfur on the left and the right, and 4 oxygens on the left and the right. So it's balanced, so we don't need to first balance our equation. So we just start off by, on our periodic table, finding the atomic masses for calcium. And we're also interested in sulfur and oxygen because they're in this compound. So, calcium, the formula mass is 40 because we've only got 1 calcium. And the relative formula mass of calcium sulfate would be 40 plus 32 plus 4 times 16. So on our calculator, 40 plus 32 plus 4 times 16, which equals 136. So 40 grams of calcium will make 136 grams of calcium sulfate. So first of all, to calculate the theoretical yield, we need to see what 63 grams of calcium would make. So if we divide both sides by 40, we know that 1 gram of calcium should make 136 divided by 40, which is 3.4 grams of calcium sulfate. Times them both by 63 to find out what 63 grams would make. So 63 grams of calcium would make 214.2 grams of calcium sulfate. So this here is our theoretical yield. So theoretically, if all of the reactants turned into products, we should make, with 63 grams of calcium, we should make 214.2 grams of calcium sulfate. This is our theoretical yield. So our actual yield is up here because in the question it said 63 grams of calcium reacted with sulfuric acid to make 153 grams of calcium sulfate. So our next step is to use these two numbers to calculate the percentage yield. So percentage yield would equal the actual divided by the theoretical times 100. So 153 is our actual. Our theoretical was 214.2, and then we times by 100. So on our calculator, 153 divided by 153 divided by 214.2 times 100 gives us a percentage yield of 71.4%. So here's a percentage yield question for you to try, combining your understanding of theoretical yield calculations and percentage yield. You've got 55 grams of iron reacted with copper sulfate to make 112.6 grams of iron sulfate. Calculate the percentage yield of iron sulfate. Pause the video now. So this, in our question, 112.6 grams of iron sulfate is our actual yield, because that's what we've actually got. And first of all, we need to calculate our theoretical yield. And to do this, we need to calculate the relative formula mass of the reactant and product that we're interested in. So we see that 55 grams of iron makes, in this case, we need to find out how much iron sulfate would it theoretically make. So we use our periodic table, find out the relative atomic mass of iron is 56, sulfur is 32, and oxygen is 16. So we need to first of all check whether this equation here is balanced. 1 Fe on the left, 1 Fe on the right, 1 Cu for copper, 1 copper here, 1 S for sulfur, 4 oxygens, and here an S for sulfur and 4 oxygens. So it's already balanced, so we don't need to balance the equation. We just go ahead with calculating the relative formula masses. So for iron, there's only one atom of iron, so that would be 56. And for iron sulfate, we need to do 56 plus 32 plus 4 times 16. And that would give us 152. So we can say that 56 grams of iron would make 152 grams of iron sulfate. We need to work out how much 55 grams would make, because that's what our question is. So we divide both sides by 56 to find out what 1 gram would make. So 56 divided by 56 is 1. So 1 gram of iron would make 2.71 grams of iron sulfate. And we need to times both sides by 55 because we need to find out what 55 grams is worth. 55 grams would make 149.3 grams of iron sulfate. Now if you'd used this number and then multiplied by 55, you would have a slightly different answer to me because I just kept the number that I had on the calculator here. So don't worry about that, just bear that in mind. If you did do exactly 2.71 times by 55, you would have had an answer here of 149.05 grams of iron sulfate. So 55 grams of iron would make around 149 grams of iron sulfate. So this is our theoretical yield. So this here is our theoretical yield. And to calculate our percentage yield, we need to do actual divided by theoretical times by 100. And our actual was over here, 112.6, divided by our theoretical, I'll use my number for this, 149.3, times by 100, which gives us 75.4 roughly, so 75% yield. So if you used your value, you might have got 75.5 and rounded it up to 76, but as long as you're doing the correct working, that's absolutely fine. There will be tolerance in the exam for any sort of rounding errors.